Hello everyone, what's up? So we've been covering derivatives and now we've moved on to integrals, but we're going to actually skip ahead a lot of the integral stuff to areas and volumes of solids of revolution because some of the other sections aren't really needed and we are just trying to condense everything. I'll be sure to do the other videos, but this is the part actually that's on my final that's in like 1 hour, so we're just gonna keep moving ahead and cram with areas and volume. So the area again of a region between a curve or two curves would involve integrals from a to b, and then these could be like the points of intersection if it's two curves. So then we would also need to find, if there's two graphs, we need to find where, if the first graph, let's say like first graph is larger than the second one, then we would do, if this is the case, then we would do integral of a to b, the larger function minus this smaller one. And so basically, yeah, that's going to be how we're going to approach these area problems involving regions of a curve. So basically stuff like, let's say we have one like this, we need to know that. And that would be, say this is our F, this is our G, so it follows that. Okay, now solids of revolution. So basically, if there's a graph, let's just make up a graph like this. And I'm going to take the area of A to B, but actually we're going to take a volume. Do you know why? We're going to revolve this part around this x-axis here. So when we do that, you're going to just imagine there's another thing here. This would make what we call a disk, and the disk method is pi area integral of a to b rx squared. So what's rx? Well, rx is going to be this radius here from the axis of revolution. So let's say this graph looks kind of like the square root of x graph. I'm not really sure if that would be it, but let's just pretend it is. So then if we wanted to know the area, and let's say a is 0 and b is 5, so it would be pi a 0 to 5 of square root of x dx. Don't forget to square that. Solving this now, we could remove the square root. So now we would have pi 0 to 5 x dx. Using our integration rules, let's just worry about the thing that's being taken the integral of. Just worry about the pi later. This would become, with our power rule, x to the second over 2. And now we're going to do it from the bounds 0 to 5. So this is going to be 25 halves minus 0, so 25 halves. And then don't forget about this pi. This is actually pi times thing. And actually, this is our FB minus FA fundamental theorem of calculus. But don't forget about this pi. We're going to multiply this whole thing by pi. So 25 over 2 times pi is our answer for the volume of that. We also have washers. A washer would be something like, if they had that same graph over here, let's revolve it around the x again. This is going to be our, you want to make it our f. Yeah, let's just keep it consistent. It's like what we had up there. A washer is when, let's say we're revolving this, say this is 3 and this is 0. You're revolving this around, you're going to get that. Imagine that shape is formed, right? But look, there's this inner center right here. You see that? And so a radius, we're going to have actually a big radius and a small radius. Big radius would be this outermost circle, this, as if it was a disk. But with the washer, we have that hollow opening here, that smaller area, so that's going to be our smaller radius. How you do one of these is pi a b, that's the integral rx, that's squared minus, or actually this whole thing needs parentheses, rx squared. Okay, So we could see, let's just not write functions for this, but we could write bounds. We have 0 to 3. So pi 0 to 3 is, we look, and our largest, the furthest away from the axis of revolution is our f. Is our f function. So it'd be f of x squared minus, and then that makes her smaller. Do you see how the g actually is closer to this axis of revolution? So that would make it our smaller radius. G of x squared dx. So that's basically disk washer, and could do some examples of this later, but that's basically the rundown. Oh, there's one more thing. So let's say if we had x squared plus 5, but we're revolving it around the y-axis instead of the x. So we'll have to turn this into a function that says x equals instead of y. So we do that. We do y minus 5 is equal to x squared. Take the square root. X equals square root of y minus 5. So that's if it's revolving around the y, you need to put it to x equals a function of y. All right? So that's basically areas and volume. I could go into in depth more of this later, but this is just a quick cram, just to remember the rules of it. And hope this helps. Hope you have a wonderful day and do something nice for someone.